So about 3 weeks back, I made a video about vertical farms for coffee and tea plantations. The idea was pretty simple, using, like I just said, vertical farms for producing these crops locally. The overhead is low. Most of the operations can be automated, and if you have these crops growing in secure, covered facility where the temperature is controlled, um, coupled with a couple of the things that I mentioned in that video, like humidity and application of fertilizer, what have you, then isn't really a need, isn't really a hindrance from growing these very lucrative crops locally. So I've been thinking about, and I've got some good feedback on that video by at least one individual. So I thank them for that. I've been thinking about, I kind of briefly mentioned this in the other video, but I've been thinking about growing trees in air, um, aeroponically. And the idea I shared, I'm going to share this again, is really simple. You have some kind of a tether going through a vertical farm or like some kind of a covered facility. It could be like a bucky structure, a dome, so to speak, where you just grow trees. And because there isn't any reliance on soil or even hydroponics, you can grow the trees in any shape or form. You can grow them upside down, right side up, sideways, what have you. So there's a couple of ways that you can do this. One is to just have a kind of tether going around, and you can grow the trees in some kind of facility and transfer the trees here, or you can actually grow them from sapling and mature them to a level where you just have them growing in these covered facilities. So there's two ways that this can be done. One is to run a tether around the trees. So the tether would be running through different parts of the trunk just to kind of support the structure. And obviously these wires have to be strong enough to be able to withhold or for them to withstand the actual weight of the tree. So they could just kind of go around, and there could be some kind of a softer kind of structure going around the trunk, and it would just hold the tree. If you Google growing trees in air and click on Google Images, then you can kind of get a snapshot of what I'm talking about. It looks like this is already happening, but it's not happening in the kind of facilities I'm talking about. The other idea, which I kind of share in the other video, I'm going to share this again, is as the trees are growing and maturing, you have a kind of like a construct that comes from the beam or however the tree is going to be supported. And say I don't have an actual, I'll just use the Kleenex box. Say if this was the trunk of the tree, then you would have kind of clamps going around the trunk and maybe softer kind of claws that would just hold the tree. And all you really need is for the tree to be able to kind of have a fixed position so that the root systems can grow and you can apply fertilizer to it through any means. It's no different from how the fertilizer is applied today for any kind of plant in an aeroponic facility where you kind of shoot the fertilizer at the root system. So now that you have the tree hosted like this, you can just, like I said, grow them in any formation, right side up, sideways, and you can then cover a very small area, or it could be a large area that you can have these distributed models of these pods or bucky structures popping up all over the place, and you can actually use the entire surface area of the structure as opposed to just the surface or the sides, because you can come up with a way of distributing the energy. And once you do that, you can grow the trees in Ontario, and maybe it's going to require a lot more energy to do that in Ontario for now, although energy abundance is coming within 10 years, 10 to 12 years. You can grow them anywhere. Like there's a huge sun belt. You can grow them here in the sun belt. You could grow them in the Sahara, anywhere really. So this would be a pretty big disruption for the kind of crops that are generally specific to geographic locations. And when it comes to the fruit and the nut market in general, it seems to be clustered around specific geographic regions. So Somebody would have to do the math in order to be able to figure out how big the markets are for specific kind of fruits like mangoes. I just had a mango. That's how I was thinking about this idea before, but I would think the mango market, the production of mangoes, if it could be ramped up in some way, then the market would grow quite a bit. That's my intuitive guess because I haven't like I've never come across anyone who would say that they don't like mangoes. Everyone loves mangoes, but the production is controlled because it comes from a specific group of countries. Same with other crops where the price is high, the production is low for a whole bunch of different variables. What it's pineapples or cashews, um, the more difficult it is to kind of commoditize the crop, the higher the price and the lower the yield. So that's my idea. It's really simple. You just create vertical farms or some kind of covered facility, and you control the temperature, humidity. I understand a couple of crops have different needs. As in, I think peaches require a certain level of humidity in the air, and there's got to be kind of like a mist or like slight frost um, around a specific part of the year, and if it's too much or too little, then it impacts the level of the number of buds that are going to come out. I just kind of picked that up reading one of the reports a couple of years ago. Whereas some like walnuts would have other requirements. I think it's either walnuts or, well, that's interesting. I just noticed something on the wall. It's either walnuts or almonds. I think it's one or the other that require a lot of water. And that's one of the reasons why there was a bit of a kind of a conversation around water scarcity in California when the drought was happening up until last year. Now it's not a problem because they've had a lot of rains. But basically, the farmers were using a lot of water, which was being sucked from the water table, and there was a little bit of an issue around that. So, but like you kind of think about it, like if you're just growing trees in climate control facilities, then there's abundance. There's abundance of food, fruit, nuts, vegetables. We can grow them anywhere already. It's already happening when it comes to vegetables. There are installations in Spain which produce majority of the produce for specific parts in Europe, and these kind of installations are popping up all over the place. So this is just my idea for the day, which is to grow trees in air. I don't really see any hindrance for doing this, and with the development, we don't even need graphene or any other advanced material for something like this. We just need good design and we need good analytics. As the tree starts growing, the structures around it kind of adjust themselves. Their only job is to be able to sustain the weight enough that it doesn't have to be too tight or too loose. Obviously, if it's too loose, it's going to like fall through the structure. And if it's too tight, it might restrict the growth of that. I don't know how that the trees really work. I think there are two processes. I think it's one is xylem and one is phloem. I could be wrong. I'm trying to recall this from memory. But it's basically pulling the nutrients from the root system. And one of these processes is responsible for taking the nutrients up the root systems through the capillaries and through the. I don't know if it works like this or just up and then down, because I'm trying to recall this from memory. But yeah, that's how the nutrients kind of go up, and that's how the sugars and all the other nutrients are picked up from the root system, and they are taken and distributed to the different parts of the tree, with the light falling on the leaves, obviously, and the whole process of sunlight being converted into energy happening in the form of photosynthesis. So yeah, that's a very bad or crude definition of the process. But it's actually a really simple process, and I don't foresee why we shouldn't do this. And I think, considering the huge amount of money that can be made by disrupting this market, whoever moves in first takes a big advantage. I believe most of the production for food in general, as in fruits and vegetables and nuts, for North America at least, comes from, if not the world, comes from California. Um, so here's an opportunity for disrupting more of the market share, bringing some of these exotic crops from other parts of the world into local arenas, and then you got to work on the other problems of water, and mostly water, because I think we're going towards energy abundance. So unlimited number of mangoes and pineapples and apricots and figs and nuts, which has been nuts have been they're expensive. If you go to Whole Foods, or I get mine from a local store. I don't buy a lot of exotic nuts right now because I can't afford. And when I mean exotic, I mean even almonds and cashews. I haven't been able to afford them for the past forever, 6 or 7, maybe longer time frame. I just eat sunflower seeds and a couple of almonds every once in a while. And I eat walnuts. Walnuts are still, for some reason, they look like they're economical. But yeah, with a model like this, we could have abundance of nuts. We would need technologies like this in space. When we go to other planets, we will definitely need installations like this. So we've got to start preparing now, so that some of the problems can be solved once we expand beyond the terrestrial Earth. The question then becomes, if the industry is disrupted, and there's big money here to be made. There's hundreds of billions of dollars to be made, if not more. When you look at the fruit and the vegetable market, at least. Well, I'm talking specifically about food that grows on trees, and this is just one way of doing it, by the way. But yeah, sorry. The question was, what happens to all the people who are displaced? Well, that's another conversation. I've shared a lot of thoughts around that in terms of doing basic income intelligently, and doing it intelligently is a whole different conversation. Society adapts. We 90% of the people, 90% higher percent of the population was involved in agriculture up until the 1700s, and then the Industrial Revolution happened, and today only 2% or less of the overall earthly population is directly involved with growing food, which includes fruits, nuts, vegetables, dairy, meat, and potentially other stuff that we eat. Like vegetable oil and stuff like that comes from it's vegetables, or nuts like peanut or canola or soy. So society will adapt. The markets get disrupted all the time. That's a whole different conversation about doing basic income intelligence. Since I am like 99% sure that something like that's going to start going through, because I just can't see a way around technology displacing or automation displacing jobs, and society choosing not to do anything about it. So that's another conversation. But growing trees in air, huge opportunity. Whoever moves in first makes a lot of money. There's sub problems to be solved here, but compared to a lot of other areas, this is an easy problem to solve, in my opinion. Because all you're really doing is, instead of growing the trees in the soil, you're just growing them straight in the air. And through a combination of technologies, through precision agriculture, through robotics, through basic materials, you don't even need advanced materials for something like this. You can start slowly displacing the actual production of these crops in their geographic location. Work on the phenotype, as in like the surroundings around the crops, so that you get a better yield. And you save money. You save money in the transportation costs. You grow it locally, which is probably going to create more jobs. And you make money. So keep it in less than 15 minutes. This is my idea for the day: growing trees in thin air. If you have any feedback, please let me know through the comment section below. Thank you and have a wonderful day.